Hi everyone, I am Ifanashira, who is majoring in Distributed System and Security. By watching this video, you will understand more on my final year project background, which is titled as Secure Corona Tracking System, Sectra, and this video will end with a short demo of the project. I will start this presentation content with the problem statement, objectives, overall modules diagram, proposed ideas, flow of algorithm, demo, and lastly conclusion and future work. The problem statements were started with manual entry and input may lead to incorrect details being shared. In any surveillance app such as the COVID-19 contact tracing app, the input entry could be automated based on the capability of the function and sensors. Second one is personal identifiable information (PII) of users are shared on the server that is leading to confidentiality issue, where the data shared on the server should be unreadable to ensure the confidentiality of data is guaranteed. The third one is sensors input data which are not protected may expose details of whereabouts that may be risky to the user. The data need to be protected and also authenticated in terms of its confidentiality and availability. This should be done for both sensors and non-sensor data. The objective is first to develop a COVID-19 contact tracing mobile apps by using mobile sensors such as Bluetooth and GPS sensors. Next one is to develop a web-based engine and also mobile app that provides security features such as anonymity, encryption, and pseudonym of the data stored. And lastly is to implement security mechanism on the data that is collected from sensors. The modules diagram are user registration, user login, proximity tracing, and also notification service where it includes the salting of password, verification salted password is true, AES encryption, and also push notification. In this project, we have developed a web-based engine and also a mobile application named as Sectra. This application will broadcast message between nearby devices by using Bluetooth. Therefore, we implement encryption on the message that has been broadcasted. To give a clear view, the process started with login and then followed by collecting and broadcasting short message. Next one is infected user is verified by the hospital, and lastly, it will notify the proximity users. The algorithm used is password salting in user's account, which is SHA-1 hash function and also 64,000 PBKDF2 iteration. Symmetric encryption with AES-256 and SHA-256 for broadcasting data. No more to worries about. It is more difficult for brute force attacks. The secret key and password are secured. We have finally reached the demo part, where I will show you 3 scenarios. First is normal user, second is infected user, and third is high-risk user. The first thing is user need to log in with your own user ID and password. Once the user credential is verified, they can enter and see the dashboard, the profile, the status, start scanning page, and also upload page, where this page is for the infected user to upload the code from the Ministry of Health. The initial process happens here in proximity tracing page, where the user need to press on the start button, so the Bluetooth will be open and the scanning will be started. In the registered user table, the test user 1 is registered and the password has been salted as shown. Next, we go to the table ID. In table ID, the test user 1 is also input once the registration is successful. So we'll be using prime user and test user 1 as the sample case scenario. The EBID will appear here when the proximity tracing is happening, and UNA is the user notified or not. For the local proximity list table, this is where the proximity data, the hello message is appear here, where it is successfully encrypted. And for the last one is COVID patient table. The data will be input by the Ministry of Health and also verified by the Ministry of Health through the mobile application and also web-based system. When test user 1 is infected with COVID-19, he needs to get the code from the Ministry of Health and enter it in the mobile application. So the data of the test user 1 in the local proximity list will be uploaded and be compared in the table ID to get the initial ID of the other user who is in proximity. In table ID, we can see that nobody is notified yet, but if you refresh it, Prime user is going to be notified, and I will show you on how it will happen in the Prime user account as we log in. In the status, we can see that Prime user is in high risk, so he needs to do self-isolation, and also he will receive a notification as alert, you are at high risk. We have finally reached the end of the video. Before that, I want to conclude that I have gained new knowledge and exposure, and then I have learned that there are many ways and options to ensure the data is stored in private other than encryption. Next is I think there will always be vulnerabilities in any security mechanism. And for the constraint this project, I think it is quite challenging to choose and implementing suitable algorithms and API, and also the limited usage of cloud service. In future, I plan to implement security mechanism if I had chances to do that. So thank you for your attention, and I hope you enjoy.